Do you want me to start? All right, I'll start. Hey, everybody, Rohit. Um, I'm trying to think what the smartest way to introduce here is. I was one of the beta readers for Sam's book. How about that? That's probably the claim to fame that's most applicable here. Uh, Long-term aficionado of all things related to coding, few things related to magic, but excited to talk a little bit about, you know, how these things actually work together. Pleasure to meet everybody.
Should I introduce myself? I don't know if that's
Yeah, do it, man.
relevant.
Do it.
I'm sure I'll tell more about my background kind of as we go. But yeah, I am
Yeah.
the author of this forthcoming book, The Magic of Code. Long time coding and computation person, although never really in a formal capacity. And I can kind of get into that about my own background within like the computing world. And yeah, I this is going to be my third book about kind of science and technology, and yeah, excited to discuss it with everyone.
Should we just go around? I'll call folks. Mert Salebi. Why don't we go in the order that this shows me in my Zoom screen?
Sure. Hi, everyone. I'm Mert. I'm a software engineer currently on a sabbatical, which is going great. My background is kind of a weird background. I started a couple companies. Most recently, I was working at a evolutionary biology company as a software engineer, leading their software team. Left that company about 4 months ago, and I'm just mostly working on small side projects.
Very cool.
And
Charmaine,
I have not written any books.
it's
Hi,
still fine.
hi everyone. I'm Charmaine, and I haven't read any of your books. I was just purely curious. I thought I'd use this as a primer before reading the books. That's sometimes what I do with these things. I have a background in design, technology, um, policy, and I'm presently in West Virginia at the university.
Great to meet. Jennifer?
Hi, I'm Jennifer, and I have a background in math and history of math. And I read your newsletter, Sam, and I really like your approach to technology and computation, sort of like finding the human element in those things. So I'm just really interested to read your book and then to hear what you have to say today.
Thanks.
Travis?
Hey everybody, Travis. I'm Brooklyn based. Nice to see you again, Sam. I lead Futures and Foresight for a global biopharma company and am currently studying complex systems science at Arizona State University as well.
Fantastic. We were there not that long ago. John?
Yeah, hi. I'm actually a lawyer, not a coder, except by proximity to being a lawyer for tech companies. Um, just recently retired from full-time work, but previously was most recently at Stripe, and before that at Facebook, and before that at PayPal. Now in New York, and after 25 years in the Bay Area.
Fantastic. Oh, I want to know more about that. And Juan, last but not least.
Right. I'm Pao. I'm from tech. I'm just here to hear about and discuss about tech and philosophy. I'd like to hear more from your book.
Fantastic. Thank you for joining, everybody. I think it's a fairly eclectic group who's kind of come together, so that's quite nice. In which case, I think maybe I'll just kick it off, and I have a few questions, obviously, that I'd like to ask Sam, but I think it would be much better if it was a free-for-all and you all jumped in and asked questions and answered yourselves as well, because I think there's a bunch of different perspectives here that can be quite interesting. I think let me start with this. So magic is a fun metaphor because magic inherently stands for something that you don't really understand how the internals work. If you think about magic generally in books or movies or whatever, it's a stand-in for, here dragons, right? You don't know what goes on inside it. Code, by contrast, is something where you exactly know what goes on inside it. by definition, because it's like, in fact, a little too much so, enough so that you kind of get lost in the weeds. So tell us a little bit about, how you think these two things come together. Let's use that as the jumping
Yeah.
off point while Charmaine is deciding whether to read the book or not.
This is great. I think there's kind of two modes of thinking about magic with technology. There's like the first, which is like I don't really understand things. I'm praying to like the gods of the cloud to like hope that my stuff gets like gets saved and backed up. And there's like, how does it work? Oh, it works via magic. There's that kind of mode of magic. But then there's the like taking the analogy of magic seriously. Specifically, if you look at like through stories and kind of history of how people thought of magic, it's it's this craft and this art of like using words and text to coerce the world around you and kind of like make it do your bidding. Um, and that's kind of what I use. So one of the chapters kind of tries to take this analogy seriously and says, okay, let's take this seriously. And code in many ways does this. Like, and it's not just like hand wavy. Like you read fantasy novels and it's like, oh, like Harry Potter had to go to school for many years, or other people had to go to like they had to have all this training. Like it wasn't just like, oh, I wave a wand and everything does exactly I want. No, it takes work. And the same thing is true with code and computation and software development. Like there's a great deal of power, but there's also a great deal of work to kind of get it to actually do this kind of stuff. And that being said, though, I will say I'll caveat it with one of the things as I was writing the book, and I discussed this a little bit in the book, is that I wonder if my own experience of code is like ideally situated for magic. So like I didn't grow up in the very, very early days of computers where they were like these big humongous things and you're writing at very, very low levels of like assembly or binary like or machine code. And I also didn't come of age now where people are actually beginning to use natural language to like to generate code, which almost in some ways feels too easy. So there's like there's the too hard and kind of like very, very, I don't know, detail oriented. And then there's like the really easy stuff. And I kind of came of age in sort of this like weird in between period. And I wonder if maybe that is the time where it's like using C or Python or whatever it is, like that's the perfect moment for code as magic. I don't know. That being said, I kind of try to take the analogy as far as possible without it like totally breaking. And I can discuss like the power of names and how that is related to variable names and things like that, and similar to naming in magic. There's also things around like grimoires, like these like books, like texts for magic. There's the same kind of thing in code, and I kind of try to show these kind of analogies. I would say, but taking a step backward from like the magic stuff, there's also more broadly just like the sense of like, and this is kind of like in terms of like to take a broader step back of like how I kind of thought about writing this and how I was thinking about it. There's also just the idea of wonder. I feel like right now in like the larger culture, like when we talk about technology and big tech or whatever, like it's really easy to just like crap on all of it and be like, oh, like social media is destroying us, phones suck, all these things, like AI is gonna take over the world. Like there's no like either it's things just get us to like it's very utilitarian, like we use tech in just kind of this very utilitarian way, or it's a cause for concern. But underneath all of
Right.
this, throughout computing history, there is this like wondrous undercurrent, whether it's like taking seriously the idea of magic, like you look back and like I think the 80s, 90s, 70s earlier, like a lot of programmers were like using magical analogies, basically basically everything from like Dungeons and Dragons or Tolkien, like they took all these terms and made them like actual coding terms. And so like there was kind of this sense of wonder of like, or things related to art, or Jennifer, you're talking about like this kind of humanistic sense, like they're like deeply related to how we think about language. And actually, if I found this, so this is the New Hacker's Dictionary, and like you just look through this and like over and over, it's just weird terms that are kind of related to magic and fantasy and like and just like fun. Like, you know, so I just opened this randomly, like Easter egg, like that's a pretty common term in computing, but like there is just this sense of wonder. And for me, it's the book was kind of my attempt to sort of rekindle that sense of wonder in computing. Because I think most people realize it's there, but it should be highlighted even more. Everything from like how computing connects to language and philosophy and art to biology or whatever it is. So anyway, I'll pause there. I've
No,
rambled.
I think that's a great point, right? I think the two things that I keep thinking of is that the magic, like I think we live today in a time when a lot of software or code effectively feels like magic, sort of almost inherently, because you can like click a button and a car comes to you, or you can ask any questions into a box and a bot will try to answer it relatively decently for depending on the question that you ask. So it feels like there is some magic that's going on inside. But if you rewind it back, what is the first piece of code that actually did feel like magic? And it's open floor, but I wanted to hear sort of for you, Sam, as well.
So I guess it kind of depends. And so I can think of a few different examples of that. So there was
Yeah.
one like something that I did not write but felt magical. So my early experiences of computing, and so I mentioned like I've never worked as a software developer, so
Mhm.
I've always kind of been like come to the world of coding as very much like an amateur, or like using it in my larger job of as a scientist or whatever it is, but never quite as like my main thing. But kind of
Yep.
always loved it. But my first experience, so the first computer my family had was the Commodore VIC-20. It was sort of like the less popular Commodore to the Commodore 64. I think it came a little bit beforehand, was soon eclipsed by the Commodore 64. And um uh so my father, so he got the computer when I was very little. He was very into it. And one of the ways in which you would get software, and you could, I guess, purchase like these like cassette tapes that had code in it. But you could also just you buy computer magazines and they would have like pages and pages of like code that you could just type in and enter. And I remember like like being with my father, probably sitting in his lap when I was so little, and like he would enter in all this code and it would result in some sort of like, game that we could play. But I also remember seeing that he would like enter it in and like weird bugs would happen. So like there would be like just a whole bunch of random characters coming out down the sound screen, like all these and that thing, like that sense of like there was this clear relationship between the code that my father was entering and what was happening on the screen felt really powerful and strange and magical. And so that was my first experience. In terms of my first experience, like doing it myself, I was always obsessed with screensavers and kind of screensaver like imagery. And I remember, I think my first experience, like making some sort of like simple, like falling snow, like screensaver like thing, that where I was like, okay, it's a very simple thing, just like a whole bunch of dots. They're all kind of doing their thing, but because of sort of the relentless power of the chip that we're just like it's going to update every single little dot over and over in some very like simple way, but like it adds up and it looked like real falling snow, and that was mind blowing. So that would be another example I would give.
Yeah, I think I remember the falling snow graphic creation. I remember sort of trying to build something like that. And yeah, I can totally see that. I think
Right, and
for
you
me, it
can
was,
get it very easily. You don't have to do anything very sophisticated. Like there were
yeah,
other
yeah,
I tried to make like flying through stars. And then to do that, then you suddenly have to like figure out trigonometry and it's a whole thing. And like that, but like
yeah,
falling snow, it's just like oh, random little things kind of going down the screen. And but it
yeah.
acted in a way that was powerful.
The rand function is actually like it's a surprisingly powerful function, I feel like. Because the power of randomness, I remember, I think to me, like one of the first memories that I have of like actually feeling awe was playing some game. I don't even sort of exactly remember which one. It was some text game from memory, like in one of these old PCs. But like distinctly remember that like when it was the interactivity because you input something and the computer does something, right? Like I mean, you don't do anything. And as a consequence, when you respond to that input, you're like, oh, there's a homunculus in there. You can actually do something interesting with this. And at theoretical level, I think at least for me was much more like Conway's Game of Life type thing. Like oh, you can just do very simple kind of quasi-random inputs, and you get like insanely cool stuff that is coming out as output on the other end.
Yeah.
And that was
Yeah, in the Conway's Game of Life,
semi mind blowing.
yeah, that's definitely another touchstone. I remember reading it in like these collections of like Martin Gardner, who like, he
Right.
was columnist for Scientific American, right? And like seeing right these very simple rules created this emergent like these emergent worlds, which were
And these worlds get ridiculously complex, which was the funny, like even now you kind of look at that and go like, if I see the complex output, can I recreate the simple input? Which I remember is a question that I had when I was like a small kid, and it's almost impossible, but like it's as a question, it's really good. And it almost feels like magic because you can create this entire world by like uttering something like in Wizard of Earthsea, Like you say the name and you can actually bring forth something actually pretty interesting.
Right, you get the true name, yeah, the right true name or the right little set, like rule set, and then suddenly it just kind of all unfurls.
Exactly. And I also think that like it's actually really weird. I want to hear from others as well, by the way. Just feel free to shout in. Uh, I think one of the weird things that I think about is like very early on, um, the fact that found this cool made it feel more like a liberal arts pursuit because it was cool. But then it was very cleanly cleaved off pretty early on and say like, no, no, no. The wonder is just a byproduct of the fact that you need to learn to code.
Oh, interesting. So, did
No?
you feel, yeah, did you feel then like the wonder was like a guilty pleasure kind of thing, or
Yeah, it was a very utilitarian wonder, I feel like, because I was like, because wonder is wonder. It doesn't kind of respect boundaries. But I, at least, I mean, I don't know whether how other people feel, but like a lot of the code felt like it was important because you could do it and it would lead to something more interesting. So yeah, this is child's play. This is fine, you can enjoy it. But the actual benefit of this is the fact that like you have to learn to code in Basic or C++ or Java or whatever your entry poison was, as opposed to saying like, no, no, the wonder is the important part. Like that's what makes you want to go do this in the first place. Instead, it kind of
yeah.
cleaved off very easily, I
And
feel like.
I think ideally though there is kind of this nice interplay between like kind of like the more utilitarian approach and the more wondering approach, which is like the people who are building the infrastructure, they create the foundation for people to make much more easily things that can be wondrous and delightful.
Right.
And in turn, like the wonder stuff can maybe draw in certain people, right? But I don't think it should be like an either or it's like the wonder stuff is just kind of like a nice little gateway. It can also be like that's the point. Like there's something delightful here and it's worthwhile like on its own. Yeah, no, I agree.
I I mean, on that note, like I feel like one of the funny, cool parts of the book is also it talks about the tools for thought movement, of which I have sort of many, many ideas. One in particular that like thought is that in many ways I feel like every era we come up with different analogies for tools for thought. Whatever the library of the mind, computation is the most recent one, ergo code, right? It being a nice like kind of segue into what thought actually even means, or like what can you actually extrapolate from that. um I think the interesting thing that I kind of keep thinking is like every generation we find new things to chip away from thought and actually place it somewhere else. It used to be memory, and after memory it became something else, reasoning perhaps, or like logic or knowledge, and then it kind of you keep taking little bits of it and put it elsewhere. So one of the funny things that I was thinking when I was reading is like, look, if we have all effectively been converted into some form of cyborgs anyway, because it's a classic question of like, if you were dropped into a desert island, what would you take with you? And like, it's a really hard question because everything that you would require needs like an enormously long supply chain that touches every individual bit of it. And I wonder when I think about like, the magic that comes from code, is part of it the fact that it actually interconnects everything and everything that we see, or everybody that we see, and all facets of life. And it has kind of done that semi-insidiously because these are congealed decisions and thoughts that we have already had.
Interesting. I'm not sure I have like a deep thought related to that, but I mean, yeah, and I mean, for me, I like the fact that like code, like thinking about code can touch upon lots of different ideas. I guess like
Right.
the downside is like, yeah, like, there's like the thinking about it that can reveal lots of different ideas and kind of view it more as this kind of liberal art. But the downside is um, it kind of, I don't know, absorbs or dissolves every other aspect of our lives, and so like everything becomes computational. Which I mean, actually,
Right.
I wouldn't necessarily say it's a downside. It just makes it harder to distinguish things. It's not. I don't think it's bad. It's just more kind of the world within which we live and have to contend. So I don't know. Yeah, that's that's
Is that a function of the fact that we have a new vocabulary, so you get to point that out, or is that a intrinsic facet of the world? I guess that's a different way of asking the same question.
Wait, what do you mean by that?
Like we now get to say that, computation is a thing that we have kind of defined in some way. The brain is a computer kind of metaphor, or, we have offloaded reasoning into that machine being a kind of metaphor. And the fact that we get to use these metaphors today is because we built these machines that can do them. So you get to point at them and be like, aha, you know, the brain is
Yeah,
not like a
yeah, I mean,
library. It's actually like a computer.
right. I mean, I feel like there's like a small set of like these like very open-ended kind of powerful metaphors, and so like
Yeah.
computer is one of them. And so sometimes it's right, like we use it because it's a very powerful metaphor. Sometimes we use it because we've already offloaded certain aspects of our existence to computation. But in the same way that like I view like I don't know like the ideas of like evolution or evolutionary biology, like these are very powerful and very open-ended. Whether or not they really fit with all the different things that we kind of analogize it to, that's an entirely separate matter. But I definitely think the fact that we have done so much with computers um, makes it easier. But it's also, but at the same time, though, like you can recognize that, um, like even just like like calculators, they can do math, but they do it differently than we might do math in our heads. And so
Right.
I kind of get to the same point, but to kind of bring that metaphor too far, yeah, right. It could also just be right. It is the kind of the metaphor du jour of like, oh yeah, it's like the most sophisticated technology we have, and so let's kind of analogize everything to it. I don't know if that quite got to what you were thinking of. But.
Yeah, I mean, it is, you can either use it as a pure metaphor pump to kind of use that and kind of, it gives you language to describe some facet of things that you couldn't have described before,
Right.
which kind of gets to that point. Like it's like the, software as crystallized thought or something, right? Which kind of gets to
Sure.
that point of like, hey, we have defined it and written it down somewhere, which means like you can reuse that piece of information repeatedly. It's like
Right.
aphorisms being made actionable.
Yeah, yeah, yeah. Oh, that's interesting. Huh.
Which is
So,
I don't know. I mean, it's a, sorry, go, what were we saying?
oh, I was going to ask if we should have other people share some of their earlier experiences and things like that. I'd be actually very interested.
Yeah, shoot. Anyone? Or should I call names? What have you guys' experience actually been generally like with code or using code, playing with it, feeling some wonder from it? Are we alone in this feeling? I saw a couple of nodding heads, so hopefully not, but
I can share one. Um,
shoot.
are we talking about like a very early one or like a recent one?
Sure.
Could be
Sure.
any.
Either way.
Cool. Yeah, I think the earliest one is probably, so I'm from Turkey. And the first time that my family got cell phones was probably like mid 90s or something. The earliest memory of like, it's like barely programming for like what we were talking about. Like there was like this like set of commands that you would enter into the cell phone that would
Mhm.
allow it to basically have like a minimal snake game. That was probably the first time that I was like, whoa, like this thing can do like I can just give it rough instructions and it can just like do stuff for me. It was probably like the first one. The second one being probably just like writing simple programs to like make this cell phone play music was like another one like for me that was just like whoa, you could just do things. It was incredible.
Right. And I feel like this, like that kind of feeling of we're like very easily like having some technology like a piece of hardware like could do something that you might not have expected initially like that like so one of the chapters I discussed is like kind of this idea of like democratization of software, and I feel like that kind of feeling for too long is kind of the province of only a small subset of people who kind of like did the work to try to figure out how to get their cell phone to do some weird thing or figure out how to like program, like do a type-in program, whatever it is. And we need ways of making that more and more accessible to everyone. And so, I mean, obviously with like certain things around generative AI, like we actually are getting there. But like one of my first experiences with some of that was with it was a piece of software that was it was bundled with a lot of Mac. I think Macintoshes, like beginning in the late 80s through like maybe the mid 90s or so. It was called HyperCard, and it was this way of programming, but like building sort of like a stack of It was like basically building like a rudimentary website that lived on your own computer. But you could use there was like a visual way of program of just making things. You could just draw on these cards. But you could also very easily start making buttons that did things. And it was this like nice way of kind of learning how to build this kind of stuff. And yeah, we just need more of those kinds of experiences because I think otherwise, right, I want people to have that sense of wonder or to have had it when they were young, because otherwise it's right, then it just becomes the province of a very small set of people.
Do you think that that sense of wonder changes or is lessened by not using code today, or lesser use of code, the fact that we use language? Or do you think there is a possibility that it's equal or it heightens because one does not need to do the hard work of learning how to code? Um,
Yeah, I mean, that's a good question. I kind of go back and forth on this, and I'm not really sure I have like even in the book, I don't quite give I don't think like a definitive answer. On the one hand, like without some of that hard work, yeah, maybe it feels a little bit less earned. On the other hand, though, like when I think of like people who are in like I don't know medical school or like they're a medical resident and they're like and like previous generations they've had to, like they had to be a medical resident and like work I don't know 36 hours straight and then they get 12 hours off and they're like oh and now current medical students they have it so easy they don't get this and like that's insane. Like of course I want things to be easier and I feel like if there are tools to make it easier that's great. And I would say for me, it's more like if you can use these tools to make it easier, but still actually feel a connection to computational thinking and what the machine is doing, that's the ideal. If you kind of use this but never quite interrogate the systems that you're creating, then it's a little bit tougher. I think the ideal is probably also having a little bit of programming knowledge and then using these tools to make it really, really easy. That's probably or using these tools and then as a result learning a little bit of how code operates, that might be the right kind of entry point for it, because oftentimes if you just kind of take whatever code you're given as a given and not interrogate it or tweak it, it might not necessarily quite get you where you want, or you'll never quite understand how it's doing what it's doing, which to be honest is fine. Like I also think like I don't code the way Steve Wozniak coded. Like he was like insanely hardcore, and like, I'm sure he thinks whatever I do is a joke. So like who am I to judge? So I think yes, in some ways like there'll always be kind of like the old guard, maybe looking down upon something new. But I view this. But I think that's very much the minority. I'm not really sure people are thinking that. I think very much people view these as like these are enablers and democratizers, and this is overall a good thing. It can still engender wonder even if it is easy. Like I mean I'm sure like if you didn't have to go to Hogwarts for as many years, like that's fine too. Like it's okay.
I mean, I would go so far as to say that if it has to be somewhat easy for many people to touch it to kind of feel wonder, right? I mean, I think it's kind of important to allow people to be able to at
Right.
least interact with
And
it
that's the
much
thing,
more.
like you can only feel that one like the wonder easily. Like sometimes if you're like on top of this, like if you're building on this foundation of like all this other stuff that people have done to make it that much easier. So like the fact that I had this wonderful experience with HyperCard, like Bill
Yeah.
Atkinson, the developer, like had to spend a lot of effort making HyperCard so that I could have that experience. And I feel like, yeah, there's a lot of those kinds of examples. And you need, right, like you want an easy path to wonder. If it takes you too long, then yeah, then it's gonna feel
A lot
really.
more people will drop off if it takes too long, right? And ultimately, that's the kind of price of doing that. The two multiple things strike me. But one interesting thing, Charmaine, from your question is also that I'm thinking is, I remember sort of in the big, like maybe 20 years ago, there used to be, or 25 years ago, there used to be a bunch of different types of programming that existed, right? Like, and you can go very low level, very high level, but you have visual programming. That was like a subset that was trying to come up and didn't really work except for like industrial control systems or something. And there was a
People retry it. I feel like every year or so.
every
There's lots
yeah.
of attempts. Yeah.
I mean, now it's called low code, no code, I guess. But like there was a bunch of attempts at trying to make these things work. And I think one interesting aspect was like when I think back to those days, there seemed like there was more heterogeneity in the outputs. Like you would get captured by one of these things and go, wow, what is that? Whereas today the heterogeneity perhaps is a little less, and it's more like, do you want to learn Java or Python or something? It's like, and you know, you can have opinions there, but maybe it's not really sure. Yeah, quite possibly.
Right. I think there's also just kind of like a narrowing of like the scope of program, or like the
Yeah.
possible, Rohit, what you're saying of like and people have talked about this where like early on in the history of computing, people thought of like there were all different ways that you could be interacting with the computer and like what the machine looked like, or how, like what kind of environment the personal computer had, or what kind of um like the style of the
Yeah.
operating system or the interface or whatever it was. And then we kind of just got locked in, and like there was sort of like this path dependence. And maybe Rohit, this is what you're kind of talking about. Of like there are a lot of ways to program and control a computer. And we've kind of narrowed it a little bit. And I think with natural language and some of the AI stuff,
Yeah.
we're opening up that possibility a little bit more, but not that much. It's still kind of like natural language to more structured language to like
Yeah.
compiled stuff versus like, no, I don't know, like paint something and like have that somehow be some sort of structured programming. Like there are people who have tried, like there are weird, like artistic looking programming languages, like that are entirely visual. Like they're not even just like connecting
Yeah.
boxes together in flowcharts. Like, it's like you make this almost like weird artwork like thing, but then it gets executed. They're very much the exception. I'm sure they're a total pain to program in, but they're beautiful and different and
Yeah.
weird. And like we need more of those experiments. And so there is this whole subculture around like the future of coding or the future of programming who are trying to think about this kind of stuff. But it really has not made inroads into the larger world. But I welcome that. Like I want there to be more of these experiments and attempts because a lot of them will probably fail, but we should be expanding that possibility of like what does it mean to code or to program or to control a machine or to make software. Like there should be lots of things like that.
I think not. I think having that is actually not having that in front of you is kind of makes you feel like coding is much smaller than what it is. Because I think in the multiple places in the book and so on, you talk about, and it's one of the things I feel sympathetic to is also that like code, many of the pieces of software that we interact with or code that we interact with or create are some of the most complicated things that humanity has ever created, right? Because these are all millions upon millions of existing decisions that somebody has made that becomes the building blocks for the thing that you want to create. Like I remember sort of somewhere I was looking at, the average, you're just using a Python library as a dependency. And if you just throw the tree down
Oh,
until it gets to it's like
they're huge.
insanely complicated. So you have to do a ton of work to kind of abstract it. But that also means like each one of those decisions that somebody has made is something you can build on top of, right? Like you can kind of build really, really, really complicated things that you couldn't effectively build before. And the only way to demonstrate how complicated that is to have different ways of interacting with it, with not just whatever pip install a package or something. It's just you need the artistic, weird, you know, painting based whatever creation, not
Yeah, or
build
whatever.
stuff, but just mess with it.
Right. No, but I also love that this idea of like we often, right, we don't realize how big these edifices are, whether it's like Chrome browser or whatever it is. Like these things are gigantically complicated. But in addition, even like simple, more kind of like wonderful or playful software, right? It only exists because it's often on top of some other like infrastructure or some foundation, or yes, these other like Python packages or whatever it is, that we often don't interrogate what they are. And so there's this, yeah, this balancing act. And then I would say in addition to, there's the kind of like the re-weirding thing, like using kind of the
Yes.
painting, but there's also like the whole aspect of like bugs and errors. Like that's the other way that we're introduced to the massive complexity and weirdness of software, is like when something doesn't work and you're like, oh, it doesn't work because of some thing that I never even thought about. And and you see this whenever they're like with CrowdStrike over the summer or whatever, like all these like weird errors, like we only realize how incredibly interconnected everything is. Or like there's this little bit of like there's some open source package that has been supported by only like a team of like two, like one part-time guy who like no one even knows, and like
Yeah.
we only discover it when like that little thing fails, or something else related to it fails. And yeah, and like and so that like bugs are often kind of this way that like they actually reveal more about the system than you realized, which is really interesting to see, and also very humbling, I think, too, which is like another kind of aspect of a lot of these systems.
I wonder what else is there in the world which is like that. Is coding kind of unique in that like debugging is the way you learn the system?
It's interesting. I mean, I can imagine like, I don't know, like argumentation or like writing, or like certain aspects of like essayistic kind of writing, maybe like where it's like I think someone said like the best way to like learn something is to like just put something on the internet and like then be told you're wrong, like to find out the right thing. It's like you just like throw it out there, you get told you're wrong, and then you learn what the correct thing is, like very, very quickly.
Right.
And so maybe that's kind of like the equivalent, like the like knowledge equivalent of debugging. But you're right, like debugging is this massive effort to like learn something about the world, and like and you also, and like both about like the system you're building, but then also like deeply like the physicality of the world
Yes.
sometimes, which I find very interesting, because like going back to like there's like the magical aspect of code, but like software, like it's software and computing, like it's not dematerialized, like it doesn't exist in some like ethereal realm. Like these are like we're building on machines that exist in the real
Right.
world, and like when they fail, and like it's like the whole like the internet is a series of tubes, like it actually is, like like that senator sounded like an idiot, but there was some truth to it, like there's something physical, and you discover it when, like, I don't know, there was this great story, I think I mentioned this in the book. Some guy was like trying to debug his like Wi-Fi, where like his internet only worked when it was raining, and like he eventually figured it out that it like had to do with the fact that like when it rained, the tree that was like blocking some sort of internet connection, it got weighed down just enough to then create a nice like direct line of sight, and then everything worked. But like, yeah, it's just weird stuff like that you would never discover until, yeah, you're confronted with these errors.
Yeah, that's an insane. Like there's a other. What was that analogy? The story of the coke dropping across the university campus. That's also in there, right? Like, or am I mixing up?
Wait, sorry, say it again. Which one?
The Coke bottle being programmed to drop across the university campus. Isn't that one of the
Oh
famous
no, sorry, I don't think
stories
I
about?
mentioned that one. I mean, that was one of the
Yeah,
first, yeah, like the first like kind of like web interfaces or whatever, or like some like internet, like early internet, or it
yeah.
might have even been pre-internet. It was, yeah, some very early kind of thing. No, I mean there was something. I mean, this is not intentional, but and there's a great story of like this the 500-mile email. I don't know if people know this one, where it was some systems administrator received, he was at a university, and he received a question because these people at this in their department, they could only send emails that would like to people who are about 500 miles away. And he's like, this is insane, like that's not how email works, like there's no physical limit to email. But it had to do with, it turned out like one system had not been upgraded, and so because one part wasn't upgraded, it ended up like timing out in some very like some like a few milliseconds. And it turned out the amount of time it took, like the amount of milliseconds, like to time out, if you like took that millisecond, like 3 milliseconds or whatever it was, times the speed of light, you would get about 500 miles or whatever it was. And like that's crazy. Right. And so like there's just, yeah, weird things like that.
I mean, what I love about that one is that it very clearly when everything about code generally is thought of as purely in the mind realm, that it doesn't touch anything in the world. Like the old Founders Fund motto, right? I mean, whatever, 140 characters, no space cars or whatever. And that's kind of saying that one of these is not like the other. Only one of this is in the realm of atoms, not the other one. And then you think about these stories and you're like, no, it's all in the realm of,
Right.
like,
It's all
this is real
around.
world.
Right, like all these data centers, like the reason they're being put in certain locations is because of like energy costs and other these are real things and like they exist in the real world and you kind of have to recognize that. And we often
Yeah.
completely forget that.
I mean, I remember was it in, now I'm mixing up sort of whether it was in the thing or not. Wasn't there a story of like a user reporting their PC kept opening up PDFs on every time they logged in, and it discovered that it was because like behind the monitor there was a barcode scanner that would scan like the monitor's barcode or something. See, and it basically triggered some unintended actions, and it kept, because he was like, I don't know what's going on. Why is it happening to me? And turns out, like, talk about congealed action. Somebody had programmed it somewhere, and through no fault of their own, it kept popping it up.
Oh, yeah, that was out in my book, but I love that example. That's fantastic.
Oh, this is a really good question from Charmaine. Do you want to talk more about that? I think maybe Sam has answers.
Just maybe the similarities between them, based on what you're talking about, is I don't, when it comes to a recipe, if someone's cooking something at home, you can always add something to it, you can subtract something, right? But baking is, you have to get your ingredients and everything, the specificities are important, right? And voila, you end up with this bread, this thing that has fluffed because it's just, otherwise it was flat. And so I'm trying to figure out whether magic and code have that kind of feel to it, right? You can't half-ass it. The minute you have a problem in the code or your magic trick, you kind of have water coming out of your hand instead of coming out from the left hand or right hand, like everything just falls flat. And
Yeah. Oh, I love this. And actually it reminds me, so so I discuss a little, like when I'm talking about like programming languages and natural languages, I kind of talk about the way people talk about how programming often sometimes has like a literary feel, and you like different programs, like different languages might feel different ways. But like the truth is, it breaks down because language is like messy and fuzzy in a way that exactly what you're saying. Like code is traditionally not. Like you get it wrong, and like code has to do something. And like it's not just literature. It can be well written and like that's wonderful, but like it has to still do something. And I feel like the kind of the magical analogies in fantasy or history or whatever it is, they have the same thing. Like you read, so there's there's fantastic series, The Magicians by Lev Grossman, and in it, and so that one has, it's like a sort of like postgrad, like a university for magic, and in it, like you see the way in which these students and like the magicians like work really, really hard, and like if you want your magic or your spell to work, like you have to take into account, I don't know, like the phase of the moon and the location and all the like, and it requires work, and like you have to get it right. It can't just feel correct. And I feel like that's like the difference between like the magic of like, oh yeah, this like it feels magical and like it's kind of cool versus like no, there is like a rigor to kind of doing this thing correctly.
There's a book, I don't know whether any of you have read it, called If Hemingway Wrote JavaScript.
So right here.
I love that book.
It's kind of weird. I feel like that's a little gimmicky, but it's interesting because it shows like there's
silly
styles of like getting things done. Yeah.
And one of the things I like most about it is purely just the fact that it just shows how you can still have style.
Yes.
Even though what you care about is function. And I think one of the things about code that I find the weirdest is that it feels like mathematics. You just do it, and the purpose of the code is whether it works the way you want to or not. But for anything even semi-meaningful or large, I feel the the only way to test it is to kind of vibe it out. Because like, yes, does it do what it wants, but like, does it do what it wants under all circumstances for everybody or for only for a few people and on in these conditions or in those conditions? Like it just the permutations increase so fast that basically whether or not it works for any function of works is almost impossible to test for anything beyond like a small trivial program, right? Like, I mean, it works on my version of Mac, but not on your version of Mac for some weird reason. Or same versions of Mac just installed differently, or like slightly different pack. Like the number of things it has to get right is quite a lot.
Yeah. Right.
It's
There's like,
interesting.
you have to like, there's the style, but then there's also just like, yeah, being humbled by the complexity and the precision.
Correct. I think there is something to the order of like, you just have to, I don't know whether it's surrender is the right word, but like you have to find some beauty. People do say that like people write beautiful code, right? I remember asking at some point of like, who's the Shakespeare of code? If it was purely an art form, and like people had answers, like whatever. Linus Torvalds kind of like apparently writes exceptionally beautiful code. You have to learn to read it to understand it, but like there's elegance and beauty to the code, like how few lines it uses or whatever it might be. One of the other things I think about is like, I think you talk a little bit about the link between is not just code, but like um the biology as a world also, which is also famously messy.
Yes. Yeah. So I discussed, so, well, so there's actually, so my last book, Overcomplicated, I kind of talk about sort of like the complexity of biology is sort of like kind of like related to like the like complexity of like the systems we build. But then I also, but in this book, I might discuss that aspect, but I would say that, but I also kind of focus on, where like biology, there's, I mean, well, some people were like, oh, like the cell is a machine or whatever. Like, it's not really true. But like biology, there's kind of two modes of thinking about it. There's like the mess and the information. Those are kind of the two that I kind of talk about, like the kind of two modes where like the mess is like, oh yeah, it's like we're creaking, leaking creatures, and like even within a cell, it's a whole bunch of things moving around, vibrating, whatever. But at the same time, though, there's like the informational mode, which is like we have DNA with like four different types of bases, by analogy with like the zeros and ones of binary, and then we can like recombine, and there's like a very clear logic between like DNA to RNA to proteins, which in turn do things. And and so there's this kind of like very informational approach to biology. Um, the, the way I kind of view it is like you kind of need to take both seriously to really understand biology. Both like it's really like the information kind of like arises from the mess. While like and the difference with computing is like in computing we really try to ignore or minimize any sort of mess. Like going back to like the physicality with the bugs, like we try to minimize the fact that like yeah, machines are deeply physical. Like we threshold things to make it binary. We'll yeah try to and we make chips in these very very clean environments. While like biology is really really messy and like it and so like these but these regularities arise from like statistical probabilities in a very very different sort of way. And so for me, one of the things that I think about, and I kind of allude to this a little bit near the end of that chapter, but I think it merits a lot more, is like so there's a number of scientists that have begun thinking about saying like arguing that biology, it's not just like kind of its own thing, but it's really it is it is a way of expanding how we think about information processing, where it's almost like computing is like a subset of this larger view of like how do we process information and how do we think about logic and computing. And biology is another example of this. And so like biology is really a way, like the more we understand it, it's a way of forcing us to realize that computing can actually be much more than what we think about. It's like, and like you can compute using, I don't know, slime molds. You can program logic gates in enzymes, but you can also just you can compute in a much more broad way. And so, and I think we need to like expand kind of the analogies and ways we think about all these different kinds of things. So rather than saying like, oh, a cell is a machine, no, it's more, it's like that a machine is a type of, it's like a subset of information processing thing, of which biology is even weirder. And kind of, and so people talk about, there's the ideas of like polycomputing. So there's two scientists, Josh Bongard and Mike Levin. They kind of coined this term as a way of describing the fact that in in computing, like each thing kind of does its own little thing, and we kind of build up modules and this nice kind of like method of abstraction. And biology has modularity and abstraction, but also because it evolved and wasn't designed kind of any sort of engineered way. Each thing often has like multiple roles, so it'll be like overloaded. Where like an enzyme might do one thing, but it could also do like 10 other different things. And like these proteins might have many different roles, or one thing might do one thing at one level of abstraction, but something else entirely different at a different level of abstraction. And which is completely different from how we think about engineering systems, but that actually could be really powerful as a mode of thinking about how we could build computers or engineering systems more broadly. And we can use biology as a way of like thinking about, okay, how much broader could computing actually be? So yeah, there's a lot of, and then I also think about like there's the whole realm of artificial life, which I can talk about too, but that's something else entirely. But I'm happy to go into that. So,
I did want to talk a little bit about artificial life, but let the bio.
yeah, and so artificial life, yeah, artificial life is really just this idea of like.
Do you guys know what artificial life is, by the way?
Yeah,
Otherwise, maybe we should.
So artificial life, and Rohit mentioned like Conway's game of life, like these kind of like cellular automata that like, with very simple rules do these things and kind of have this like lifelike behavior. But artificial life is this broader like branch of, I don't know, I'm computer science. I'm not even sure
Computing.
Yeah, sure, we'll call it computing. But it was like very hot in like the early to mid to late 90s, and then kind of dropped off the like I guess the most people's radar. It's still kind of doing its thing, and I think it's become more popular nowadays. But it really is ways of like it's programming at least subsets of lifelike behaviors, whether it's like programming evolution in a computer or programming certain things around adaptation or whatever it is. And trying to see if you can like embody certain aspects of life within code, but also so there's kind of the classic definition of like artificial life is life as it could be. Because like right now, like we have, I mean, there's a great diversity of life on Earth, but like in terms of like what is life, like we have like the experiment has only been run once. We have Earth, and that's it. And so the idea is like to take artificial life seriously, you would say, okay, if we could rerun the tape, what kinds of organisms could we get, or what kinds of behaviors could we get, and is it possible to do these things within computers? And so, so artificial life might might see, okay, what are the features of evolution that give us certain complex behaviors, or can we create some sort of computational primordial soup where very primitive programs compete within a machine and do interesting behaviors arise? And it turns out the answer is yes. You get like you get parasites, and you get like certain things around like certain types of systems become more efficient or whatever it is. And so people tried to do this kind of thing. And then there was a big burst of excitement in the 90s. Then it kind of went away. Although I have to say, actually, I think in Japan, a lot of the research kind of continued. That's the one area, and a lot of the Japanese research is now moving slowly back to the United States, which is interesting to see. And so I think of it from like the very U.S. centric, like where it's like, okay, like you didn't see much happening for a while, but it was still happening outside the U.S. But yeah, so artificial life is another really interesting thing where it's using computers as this like in the same way that you use a microscope to understand like the cellular world, or a telescope to understand astronomy. You can use the computer to actually study life as it could be, which is super wild.
Well, one of the things that I like most about the A Life stuff is like it is the most, and maybe Travis, you have thoughts here. It is the deepest part of using pure complexity as a way to build up and see intriguing things happening. Because at the bottom, most of them have relatively straightforward rules, and it's just about building them up, multiple layers of abstraction, and trying to see what you can come about. And I kind of like that just because you know exactly what's going on at every layer of abstraction, so to speak. And it's like a nice counterpoint to many of the artificial intelligence stuff that goes on today, of which I'm a big fan. But like it's almost the reverse, where it demonstrates a behavior, but then internals are fairly inscrutable because you don't really know why it says exactly the thing that it says beyond the fact that that's what it happened to have learned from its weights or whatever. It's very tautological.
Yeah. No, there's yeah, I love these kind of I prefer like this broader set of like these like emergent microcosms where you have like these simple sets of rules that kind of like build up huge amounts of complexity, and it's yeah, it gives me hope. Yeah, there's some interesting like fundamental rules for all the for all these things that are happening. Yeah, right. Versus some of the AI stuff where it's like, yeah, they're very complicated, and you get complicated stuff out, but you're not always there's not some like fundamental simplicity kind of underlying some of these things.
It actually kind of it brings me back to a thought that I had like earlier for the prompt of like thinking about like the thing that you found magical like early on, and like I don't know that this was I certainly wasn't like the first example, but like something that came to mind was like the MySpace days. I feel sometimes a bit nostalgic. It's like I know I have friends who never in a million years would they ever call themselves like fluent in code or have
Mm-hmm.
maybe never touched it again in their life, but like back then there was this pull to sort of like, oh, I can do interesting things here. And so like I'm going to learn a little bit of like HTML and CSS to like inject code and like do, and it's sort of like this question of like how many affordances are there, right, that you give people to actually play around and come up with new things. And then I think about like this sort of like the explosion of life and all these different things that are there. It's like the more opportunities you have, like the greater range of like an adjacent possible that you give people, you're going to start to see these weird things emerge, and then they can be adapted into like these strange contexts, and people will find uses for them that you're like, wow, I would never have thought of that, right? It was never the original intent, maybe, of the thing that was created in the first place.
Yeah, I think like that whole kind of like right like remixing culture of like combining things together and recombining in ways that are unexpected. And I have a chapter about like open source, but really kind of using it more as like the like as an excuse to talk about exactly what you're saying, which is like there is a great deal of power in allowing people to use building blocks in ways that are unexpected. And so like when a friend of mine, so she was involved in building this like computer programming environment for kids. And she said like she was constantly surprised by the things that these kids made. And like that's the hallmark of like a really open-ended system is because like if the creator like can't anticipate what's going to be happening, like yeah, then there's lots of things that can be possible. Like, so whether it's like the open-endedness of like all the different things that people can create, or the remixing things to then build further things that can then be used as like additional building blocks, which then other people can take and kind of make their own. Like that is a super powerful open-endedness. And like going back to like the MySpace stuff, like I feel like as some of these systems, like as web design has like gotten a little bit more sophisticated, like we can sometimes close down those possibilities because
Yeah.
like you can't do, and so like I remember like yeah in the 90s building my own websites, and like it was super easy because like every website kind of sucked. Like it was like the barrier to like yeah, it was a very low threshold. Like to build something fine, like it was very easy because like nothing was really that good. And now you have all these frameworks that are very sophisticated, and like, it's harder, and so you can't really do that like easy. You can't just like look at like view a website source and be like, okay, now I can kind of build this thing on my own. It's like much more daunting. It's like you look at it and you're like, oh no, this is just like gibberish. Like could be full on gibberish, like because it could be like minimized, like yeah, minified or whatever it is. And that really, yeah, it kind of closes off that sort of remixing possibility.
I like the word affordances that you used there because, like, effectively, it's about, I mean, if there's one theme here, it's about the fact that the more you let folks play around or test new things out, the more interesting or interested they might be in the final whatever comes out. And whether it is about new programming languages that look cool or whether it's about, messing around with HTML, whatever it might be, these are all new ways of doing effectively that, right?
I love that. Right, yeah, you want ways, right, to make things like yeah, to make it your own, and yeah, rather than feeling like you're just being kind of given something. And this actually going back to like my own little first experience with like these like type-in programs with code. It was like there was this erasure of the distinction between user, like creator and user. And again, I want more of that. Like I don't want it to just feel like, oh, like I'm just kind of being given this thing and there's only one way to use it. Like I want there to be, right, lots of ways to kind of play with it
Yeah.
and make it my own.
This like it's also the question of like, whatever, a whole other huge topic of like, are video games art? And part of the question that goes plus and against is effectively the fact that it's interactive. To the question of are people who play it, are they creators or are they users? And like the answer determines a little bit about whether you can consume it or not.
Oh, interesting.
In a way, it's about increased affordances make it very hard for you to be a simple consumer, right? In some sense. Maybe.
Huh. But I feel like, but more like, I don't know, yeah, more ways to consume means, I mean, and now we're gonna have like this debate about the games. I don't even play that many games, but like I feel like the more affordances there are, like more different ways to use it means that you have to just work harder at making a really good piece of art. Like that's the thing. Like if there's only like one or two ways of consuming it, like that's, I mean, it can still be a work of art and it can still require effort to make, but like it doesn't mean that that's the only way to do it. It should be like it's even more interesting.
No, because you have to give a space where other people get to play around and mess around and build more stuff and test and whatever, as opposed to saying, I have a vision of what you want to get out of
Right.
it, and like that's what you get. I think affordance is
Right,
effectively is a way of giving that up.
Right, it can be an open-ended vision though. Like and like so one of the things
Right.
I talk about like with the open source stuff is like you look at like examples of like I don't know like ancient Greek mythology or like certain like storytelling traditions like these were constantly remixed. It was like and so
Right.
like Greek mythology like I would say like those are amazing stories. I like my kids read them all the time and like they love them. But like there's no real like canonical single version because they were just like modified over time and kind of and so and I feel like there's something there. Like it's okay to have this kind of like collaborative, open-ended thing that still can result in art, and like that's awesome.
Yeah, that's actually super interesting. I'm trying to think like, mythology and literature are some of those things where they evolve quite a lot in retellings and recreations and mutations and stuff over a long period of time. And some parts of that end up being the replicable bits that goes into other stories as
Right.
memes or whatever.
Right. It's like a
And I
very like
wonder,
evolutionary process. Yeah.
yeah, as
And
opposed,
yeah, so when you all were talking about artificial life, I hadn't heard the term, but it sounded familiar, and maybe it was. And so I quickly did a check, and so I was thinking whether it was Tamagotchis, right? Um, and the Tamagotchis actually, and so it's suddenly making me think, the fascination with that at one point of time was that because it felt similar, right? There was an affinity, but it also lost its luster at some point or its magic because it only did 5 things or 10 things or something, and it didn't evolve from that point of yeah. And so how does that interplay happen?
Well, this is and there's actually it's so related to like the artificial life stuff. There's actually this broader field called like open-endedness, which is like how because like what like how do you get truly open-endedness, like open-ended variety? Because like we are like a lot of like evolutionary computation might be evolving to optimize something or like choosing between a few different possibilities, going back to like the Tamagotchi kind of thing. Versus saying like, no, how do we go from like a single cell to all of the biodiversity that we see on the planet? And like and that question of like how do we get true open-endedness? Like I'm not really sure we're even close to answering that question yet. And that's something I mean, computer scientists are trying to understand it and biologists and like all, but it's like a very it is an open-endedness is an open question. But I think um like software and art, like these things are all kind of like trying to answer certain parts of that of like how do we create environments or situations where these things continue to grow in ways that are unexpected, even like based on just like the initial rule set or whatever it might be.
It strikes me that like um, another through line over this entire thing is that if you think effectively, the reason code, computation, things like that are close to magic is because you can effectively create spells and give it around to people, and you can build on top of other people's spells so that you can build crazy edifices of any form that you wanted. Then it seems like, either writ large, there's a reason a large amount of any other like science or whatever could also be seen in some ways as magic in a similar, because you have to build on top of things, right? It's just that code happens to be extremely um, code happens to be very user facing. Like in science, like if I think about things that I studied, like you don't really contribute to science until you're at the very frontier, but you contribute to code all the time, right? Like because you can just create something new. You contribute to engineering because you can just make a silly little bridge or whatever, and like it's something new that you're creating off the top of it. But there's something there to the idea that like it's one of the few places where if you're interested, you can use a bunch of these tools that are lying around and ways of thinking and start contributing a little bit back.
Yeah, and this actually, so my friend who built this software, like the coding platform for kids, one of the things she talked about when we were having a conversation about some of this is like programming is one of those things, like, especially if you're a child, like there's a lot of things you can do as a child that are like the kid-friendly versions of things where it's like, oh, like yeah, like you're doing something, but it's like you're not doing the real thing. But like coding, you can pretty easily do the real version. Like you're not building like production code and like, but like you can do
Yeah.
like you can do the real thing pretty easily. And we had a discussion about like, because I jokingly said, oh, like the easy bake oven is not the real thing, but she's like, no, 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 the easy bake oven, like it actually is cooking, like it's like a very hot light bulb or whatever that like allows
Yeah.
you to cook things. And that's sort of like the exception that proves the rule. Like it's one of the few examples where like a kid can actually bake for real, like a little kid. And like I think what you're saying is right, like you can very easily get to the real thing in a way that, right, with science, like there is this like massive burden of knowledge or a great
Yeah.
deal of effort like to get to that to get to that frontier before you can really make contributions, which is often, I think, actually, in terms of like thinking about scientists and like science, like oftentimes people are never actually exposed to what science really is. You're just like exposed to like recapitulating things or doing problem sets. And like that's not science. Science is like not knowing the answer and it being messy and human and weird and like and like that's crazy. And like that people are not ever confronted with that in like in education, like actually the weird part of science. And I feel like code is one of these interesting things where like, yeah, maybe you can get to that, not necessarily to the frontier. You're not necessarily making like computer science advances, but you're actually building real things in a way that other fields do not. And like going back to like the democratization stuff, it's now even easier where like you don't have to, like if you want to build an interesting app, like an interesting iPhone app or whatever it is, you no longer have to only limit yourself to the kinds of things that can get you like, I don't know, huge amounts of venture backing or whatever it is. Like now, because there are lots of tools, like it's actually really easy to build something that only you would use or you and your family would use. And like that's great. Like, and so the more ways we have that, the better. And I don't know if we're ever gonna get that for science, but that could be interesting too.
What's one of the things that like you find the most wondrous in computing today, apart from AI?
That's a good question. One, I don't know if this is the most wondrous. I find it like I'll say curious because I'm still trying to, but like that. So like everything we have right now is like based on like digital computing, like the kind of like zeros and ones and kind of like the traditional sense. But like there is this whole earlier history, and it actually coexisted with digital computing for quite some while of like analog computers. Like where analog computers, they weren't just like, oh, it's like analog, like where it was like a continuous variable. It was like machines and programs were built on like physical analogies, where like you would like where the actual like resistance within some circuit would mimic some sort of differential equation or whatever it is. And so people actually used them, and they were actually very fast, and they were very good for certain types of modeling and things like that. They obviously fell by the wayside because digital computers were much more general purpose. But we're actually seeing the comeback of analog computers, and like and for specific cases, and like they're actually being, and so it's not quite AI, but like they are being used for AI. But like the fact that like analog computers are actually still around and still being used, that feels to me interesting and weird, and like it's not quite wondrous. If I had to like choose something wondrous, I would probably choose like certain things around like creative coding and generative art, and like build using like simple, like very small chunks of code that make these like insanely complicated things that are kind of like modern day screensavers or whatever it is. That's kind of like probably one of the things that I find most wondrous. But like the fact that analog computing is still around and kicking and actually is very powerful in certain things, like that's kind of wild. So I don't know. I don't know if that's the best example, but I find it fascinating.
I'm trying to think of what's the most interesting recent analog computing device that I saw, and I actually can't remember.
And
I,
and there's, I mean, like people are using them for certain things, like in neural nets, like because like they're actually really good for certain types of like AI computation, which is weird but amazing. And I went down this whole rabbit hole and like talking to people who are actually involved in this space of what it would mean to actually create like the equivalent of like a supercomputer, but one that is analog, like an analog supercomputer. Like what would that even mean? It turned out it was probably a ill-posed question, and everyone kind of was like, that doesn't make any sense. But it's like these are fun things to think about.
there was isn't it ENIAC? Many like the one that was the thermodynamic, no, like a fluid-based
So it was called
economy simulation.
the Moniac or the
The
Moniac. Like
Moniac.
it was like for money. It was actually, so it was in like the like late 1940s. It was fluid based. It used water. And it actually would model an entire like country's economy based on like water, and like the height of the water in various pipes and tubes would be related to like inflation and other things. And it was like this very visually appealing kind of feedback thing. And it yeah, like, and I think people kind of thought it was like a weird, like, just like fun, like
Yeah.
strange, gimmicky kind of thing. But like, it actually gave people, I think, like intuitive senses around like how, oh, you do this kind of thing in monetary policy, and it actually will have this kind of impact. And like those kinds of interesting feedbacks yeah, they're really powerful.
And it's very hard to learn without it. I remember first
Yeah.
learning about that, and not learning. I first remember coming across a concept while reading a Terry Pratchett fantasy book, and I thought it was just like a funny thing. And turned out it's like a real machine. You can go see it.
Yeah. Yeah. It's so I think somewhere in the UK there's one of them.
Yeah, yeah.
My
There's like that's it just kind of absolutely blew my mind that like, oh yeah, you can actually go, I think it's in the science museum, but like um it was absurd that you could actually just build this thing and have the fluid levels actually move back and forth, and you now know based on interest rates what the monetary policy should actually be. Like, who would have thought, right? I mean, that's kind of crazy.
And this is like a lot of analog computers. Like they were like deeply physical and like visual, like where you would like look at, and it's like the was it the differential analyzer that was like kind of like
Yeah.
one of the most sophisticated analog computers created by Vannevar Bush. And like one of the versions of it was just like a whole bunch of like spinning cylinders, and like you could like look at it and like based on that figure out certain things are in differential equations. And it had some sort of electromechanical stuff as well. But right, it was just like it's just there. It's like a whole bunch of like rods or whatever, and like things doing their thing. And yeah, and that's like it was computing, and it was a very, very different kind of computing. But that was, slide rules. Like slide rules are analog computers. Like
Right.
they were deeply intuitive.
One of the funny things that I think about is that based on this, that's making me think at least, is it's funny that if you know more about how code is like magic, in a funny way, it becomes more comprehensible and you can kind of mess around with it and know when it breaks down. But when you don't, everything just feels like it is actual magic in the sense that,
Right.
capricious
It's like the
gods will make it
inscrutable
work or
magic
break.
versus like, right, the inscrutable magic versus the the magic is
Yeah.
craft kind of thing. Yeah.
Yeah, exactly. I think it's like it is interesting because like in one of them it feels very like there are no rules. It just happens or not. It's like a Greek mythology kind of play, right? Like gods are
Yeah.
capricious, anything can happen. Whereas like once you start thinking about it as like actual craft magic, then it's like, oh, sometimes this happens and then sometimes this happens, and you can mess with the system. And if you poke it here, then this might happen, and you actually start thinking about it a little bit more as a craftsman, which is kind of cool.
Right. And it
When you
becomes
think about
much more, right. It becomes much more approachable and manageable.
Yeah, exactly. Because you can go around and mess with it. I know we only have a couple of minutes left until we drop. Anybody else want to kind of chime in? Thoughts, comments, questions, ideas, books, essays, blogs, videos? All welcome.
I'm just curious if you might address in your book just the coming of quantum computing, and will that create kind of a new type of wonder for coding, or not really?
So I don't address quantum computing in my book, mainly because I probably don't know too much about it. And I was like, and I make it very clear, like the book is like very much like a personal exploration of like, these are kind of a few like signposts of things that I'm focusing on. That being said, like the the quantum computing and like programming for a quantum computer, from what I understand, is still very much like a difficult task. It's not one of these things where it's like, oh, now we have quantum computers, then like all problems are solved and everything is trivial. No, it's like even like was like the Shor's algorithm, the one that allows us to presumably have like very rapid um like factoring of like large numbers that would kind of break certain things around encryption. That was like a very non-trivial algorithm to develop. And like it's not one of these things of like, oh, like because I feel like a lot of the popular imagination around quantum computing, it's like, oh, it's just looking at every single path and everything becomes very easy. And no, it's this very difficult task of like figuring out how certain like superpositions become like overlap and then cancel each other out in like in ways that I don't fully understand. And it's hard work. And I feel like in many ways it's still similar to the hard work of more traditional coding. So I still think there'll be certain aspects of like magic and wonder there too. I just don't really know enough about it. And it felt a little, I think when I was writing it, I think it just felt like a little too far off for me to discuss. Maybe it's getting closer now. I don't know, but yeah, so I don't, it's not, I don't deal, I don't think I deal with it at all in the book. Actually, yeah, like two things that I feel like on the one hand, like I probably should have discussed, but I really didn't, were like quantum computing, didn't discuss it. And then anything related to like crypto and Bitcoin, I think I have like one throwaway line and that's basically it. And then just kind of like, I was like, okay, there's enough other things I want to talk about. I don't need to like discuss all the other thing. AI does make an appearance, but kind of in a sort of different sort of way than I think a lot of other people discuss. But it's in there too.
Anyone else? Thoughts? Going once, going twice.
This was
All
great.
right. This was wonderful. Thank you for joining. I highly recommend checking out the book. It's pretty amazing.
Okay.
I, I think
This
it's also
conversation
like
was a lot of fun too. So yeah.
it was. I mean, I just want to put this plug saying that like it is work because most books about computers or computation is effectively about, hey, here's why you should go learn and go become a coder. And if you want to do that, totally cool. It's interesting and exciting. But I think very few books talk about the fact that like it is one of the few ways that we have in today's world of like touching and moving, changing things in the real world. And that is what actually makes it really like craft magic. Um, and you get to know about a ton of different weird niches, a lot of which I didn't know about, like this, the weird painting languages in order to kind of like there are so many of these things that goes on in the world that are incredibly interesting and you never hear about them or know about them outside. And you kind of should, right? Because it widens the number of affordances or it widens the amount of ways in which you can think about the world. So I would recommend it.
Thank you. That's very kind.
With that, I bid you all adieu. Have a wonderful rest of the day, afternoon, evening.
Thank you all. This was great.
Thank you.
Bye, everybody.
Bye.